Welcome back to the playlist of videos on hypothesis testing. In this video, we focus on hypothesis testing, type 1 and type 2 errors. Let's get into the video. Once the null and alternative hypotheses are formulated, they are tested using a method that is often referred to as hypothesis test. There are chances that the result of the test can go wrong. That is, H0 is rejected when H0 is true, or H0 is not rejected when H0 is false. It is not possible to avoid errors, except when the test is carried out on the whole population, that is via census. Using a sample, which is after all a chance outcome, to make the decision do result in errors at times. Not rejecting H0 when it is true and rejecting H0 when it is false are indeed the desired results. Rejecting H0 while it is true is an error and is called as the type 1 error. And not rejecting H0 while it is false is also an error, and that is called as type 2 error. Let's look into some examples. According to a reliable statistical report, 78.6% of domestic flights arrive on time, meaning within 15 minutes of the scheduled arrival time. Suppose an airline not having a good track record announces incentives to be paid if the airline's on-time flight arrival exceeds the industry average. Sample of randomly selected flights of that airline are recorded with arrival times for the current month. Null and alternative hypotheses for this case are H0, that is pi equals 0.786, and HA, that is pi is greater than 0.786. If the incentives are paid, that is H0 is rejected, though average on-time arrival has not exceeded the industry average. That is, it is wrongly concluded that there is a strong evidence that suggests that pi is greater than 0.86. Then type 1 error is said to have occurred. If the incentives are not paid, that is H0 is not rejected, though average on-time arrival has indeed exceeded the industry average. That is, it is wrongly concluded that there is no strong evidence that suggests pi is greater than 0.786. Then type 2 error is said to have occurred. Type 2 error in this particular context is more concerning because that can lead to employee demotivation as compared to incurring type 1 error. Let's take another example. A drug company makes a claim that its latest drug reduces the growth rate of pancreatic and colon tumor that it concluded from its animal studies. The drug company initiates clinical studies to validate its claim through a local certification authority. Suppose mu represent the mean growth rate of tumor among patients administered with this experimental drug, as estimated via the clinical trials involving randomly chosen patients with tumor. The null and alternative hypotheses that would be put to test are H0 colon mu equals the mean growth rate of tumor among patients not administered with this experimental drug. HA colon mu is less than the mean growth rate of tumor among patients not administered with this experimental drug. Null hypothesis claims that the experimental drug is not effective, and alternative hypothesis claims that the experimental drug is indeed effective. Type 1 error in this case would mean the experimental drug is concluded effective when it is actually not. And type 2 error means the drug is concluded not effective when it actually is. Type 1 error in this context is perhaps more concerning since the less effective experimental drug will replace the current one, which is more effective. Therefore, the type 1 and type 2 errors have their own significance depending on the context of the hypothesis test, and they need to be managed accordingly. Having understood that the type 1 and type 2 errors cannot be avoided in a sample data based hypothesis test, we need to understand what choices influence the frequency of incurring those errors. and how to manage them correctly for desired results. The probability, that is the long-run frequency of occurrence of type 1 error, is denoted by alpha. Alpha is called as the level of significance of the test. Alpha equals 0.01, for example, implies level 0.01 test. On the other hand, probability of type 2 error is denoted by beta. Standard hypothesis tests provide a means to control alpha. That is, provide a means to manage the risk of type 1 error. If alpha is set to 0.05, then the test would incorrectly reject H0 5% of the times. That is, when the test is repeated over a large number of times with independent sample chosen each time. Similarly, if alpha is set to 0.01, then the test would incorrectly reject H0 1% of the times. Smaller the alpha, lower is the risk of type 1 error. Makes it even more difficult to reject H0 when H0 is true as alpha reduces. Though smaller alpha reduces the risk of type 1 error, it eventually increases the risk of type 2 error, that is beta. Therefore, a balance is required to be ensured between alpha and beta. Since the consequences of type 1 and 2 errors are context dependent, the best strategy would be, after assessing the consequences of type 1 and type 2 errors, choose the largest value for alpha that is acceptable given the problem context. In other words, don't make alpha smaller than it is required to be. Suppose water from the available water bodies in a locality is suspected to be contaminated with lead beyond permissible limit. The regulation authority conducts a test to examine and decide on suitable action. The null and alternative hypotheses that would be tested are H0, that is mu equals permissible limit, and HA, that is mu is less than permissible limit. Type 1 error in this case means concluding that the water is not contaminated when in fact it is. Such an error can result in large-scale health risk for the community. Trying to reduce the type 1 error by reducing alpha would result in increasing the risk of type 2 error. That is, concluding that a water source is contaminated when it is not, and thus resulting in shutting down that water source. Shutting down a water source when they are scarce would be undesirable as well. Therefore, alpha value has to be revisited, increased in this case, to strike a balance. That brings us to the end of the second lecture on hypothesis testing, type 1 and type 2 errors. We discussed on possibility of errors in hypothesis testing, type 1 error and alpha, type 2 error and beta, controllability of type 1 error alpha, influence of alpha and type 2 error beta, and how to balance between alpha and beta. In the next lecture, we'll focus on applying the concepts that we have understood so far on hypothesis testing and type 1 and type 2 errors. See you back with the next lecture soon.